Today is Thursday, January 25th, 2024, and I'd like to review the midterm examination in AP Physics from yesterday, January 24th, Wednesday. So let's start at the beginning and look at the multiple choice. Starting with problem number 1. A ball is released from rest on the 20th floor of a building. After 1 second, and it's from rest, the ball is fallen exactly 1 floor. Assume air resistance is negligible. What is the number of floors the ball would fall in 2 seconds? So this is a D is equal to 1/2 AT squared plus VIT, but VIT is 0. So when I put 1 second into this equation, I get 1 floor. So what's going to happen when I put 2 seconds into the equation? Well, when I put 2 seconds into the equation, it's going to get squared, and I'm going to end up with 4 floors. And so the best answer is between 3 and 5 floors. If you understand that, you can just fast forward ahead in the video. But another way to do this is to figure out what the distance actually is for 1 floor. So if I said distance is equal to 1/2 negative 9.8 meters per second squared times 1 second squared, right? My distance is going to be 4.9 meters. So I know that 1 floor equals 4.9 meters. So I could do this again, but put in 2 seconds. D is equal to 1/2 9.8 times meters per second squared times 2 seconds squared. 0.5 times 9.8 times 2 squared is equal to, so my distance is 19.6 meters. And I know that 1 floor is equal to 4.9 meters. So if I divide that by 4.9, I get 4 floors. So there's another way to do the same problem. Number 2. 2 students want to determine the initial velocity of a ball thrown straight upwards into the air. One student records the height with a meter stick, and the other determines the total time the ball is in the air. Which of the following could be used to determine the initial velocity? So the ball goes up, they measure the height to the highest point, and then the ball comes back down again, and we have the total time. So during the test, it was brought to my attention that the first 2 equations were missing time, and I said it was a typo. So I think I'm going to accept different variations as far as grading goes. But looking at the question the way it was written, A and B are out because they don't have time, so the formulas are wrong. Looking at C, VF squared equals VI squared plus 2AD seems like it would work, right? Because V top is 0. V top is 0, and I have H, that would be the distance. I could find VI. So if we read the rest of C, from the moment in time in which the ball was released to the moment in time in which the ball reaches the highest height. So that's going to work. So why is D wrong? D is the same equation, but it says from the moment in time in which the ball was released to the moment in time in which the ball hits the ground. For the entire trip, the displacement is 0. So if I put 0 in for the distance or the change in y, then this can't yield me. This is not enough information here, because this whole term becomes 0. It's not enough information for me to find VI. And the third one on the front page, I have this graph. This is velocity versus time. So what do we want to recall? If I have velocity versus time, the slope will equal the acceleration, and the area is going to equal the displacement. A mass traveling in a straight line has the velocity versus time graph shown above. Which of the following correctly describes the position and acceleration of the mass from 0 to 4 seconds? So 4 seconds is way out here. And our choices are regarding the average acceleration and the final position. So let's do final position first. Final position is going to be the area. So this shape here is going to give me a positive area. And then this shape down here is going to give me a negative area. So without doing any calculations, we can see that the positive area is greater than the negative area. So with that in mind, the final position is going to be positive. So the ones that say final position is negative, those are both out. So we're left with our choices A and B. The average acceleration and final position are both positive, or the average acceleration is 0 and the final position is positive. So the question is, for this time here, does he have an average acceleration that's going to be positive or that's going to be 0? So remember that average acceleration is equal to the change in velocity over the time. So in this situation, his initial velocity is 0, and his final velocity at 4 seconds is 0. And so his average acceleration has to always be 0. And, this is a little confusing because you started calculating the slopes and you weren't sure exactly how to average them. There's a computer simulation that we did at O-Physics, and you can move around the velocity versus time graph, and it automatically will generate, or it gives you calculations at the top that show you the displacement and the acceleration. So that's part of the reason why I like this problem. And in this video, I think I'll put a quick picture of that simulation and how you can play around with that simulation a little bit and prove to yourself that this situation is true.